Okay, I'm recording now. Let me just do a very brief recap. Today, you should, or as soon as possible, you should submit the draft of your paper, the submission draft of your paper to Dr. Ayers by emailing it to him. You can just attach it as a PDF with Jopley in all caps in the subject line. You'll write a short email, dear Dr. Ayers, please find attached, blah, 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 right? But that's not really the important part. The important part is email it to Dr. Ayers and make sure it has Jopley in the subject line. He's expecting these to come from you. The second part is this week we're going to talk about the peer review process. By next Monday, you should have returned the review for the paper you were assigned. And you do that just by replying to the email you got from Dr. Ayers. You can either write your response in a separate file and attach it as a PDF, or you can dump it in the email. I would suggest that writing it separately. That'll just be easier for everybody. Okay, I think that's all the business stuff. Any questions, comments, concerns about any of that?
Nope.
Okay, let's talk about the peer review process. So we're kind of jumping ahead because next week we'll come back and workshop the papers that you guys just finished up. So we'll do sort of an internal review as well. It won't be anonymous, but that's what we're doing next Monday is we'll workshop the papers you just did. Ideally, I'd like to do that right now, but the Jopley schedule is such that we need to do peer review first, and then we'll talk about your papers. So let me give you just a brief idea of the concept of peer review. Peer review is sort of the scientific gold standard for publication. It means that somebody who is an expert has done a fairly thorough review of what you have written to look for scientific errors. That's the idea behind it. So if another expert reads your paper and notices that you have done something wrong, or there's a problem somewhere, your math is off, whatever, that is the goal here for peer review. The example I like to use is there was a paper published several years ago, and you can actually still find stuff on it. So if you just do a Google search for the ratio of positive to negative feedback, you will find several scientific papers that tell you what that ratio needs to be. They will give you a number. So, for example, there's a paper in the Harvard Business Review that claims that you need to have a ratio of 5.6 to 1. So 5.6 positive interactions for every 1 negative interaction for a well-functioning team. There are all kinds of numbers. The way this all started is because there was a British economist who teamed up with another British economist and a Chilean mathematician and published a paper that claimed they could precisely calculate the number of positive interactions to negative interactions, the ratio you need to have for positive mental health. And that number was 3.97, blah, 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 blah. And in the paper, they claimed that they had calculated this from a physical model. It turns out the physical model they had used was basically the Lorentz system. So if you've ever seen the picture of a butterfly, the butterfly diagram, right? The strange attractor picture. Do you guys know what I'm talking about?
Yeah,
I think so.
Let me pull it up because it's a famous one. So Here it is. Oh, come on, thing. Okay, well, this will work. So it's this picture right here. Let me turn on my. This is several different versions of it, but these pictures, this one, this is the Lorenz attractor. So this is the prototypical example of chaos, mathematical chaos, right? And what this is this is trajectories through phase space for a simplified model of the weather, of the atmosphere, very simplified model. And Edward Lorenz was a meteorologist. He was working on the very first numerical weather prediction models. So the idea that you could use fluid dynamics to calculate what the weather was going to be like in the future. And he discovered that these models were chaotic in the mathematical sense, okay? It turns out that this fellow in Chile, this mathematician in Chile, was using the same system to make an argument about interactions between people, positive to negative interactions between people, and had completely misused this thing. But he was submitting, the paper was submitted to a psychology journal. And essentially the psychologists were just bamboozled by the math. This guy had this really fancy sounding math where he talked about phase space trajectories and nonlinear cascades and blah, 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 blah. And it was complete and utter garbage. As of last year, that paper, which is complete and utter garbage and has since been retracted, has been cited over 3,000 times. Okay. So the basic problem here is that that was not peer reviewed by somebody who had enough expertise to notice that this was just garbage that this guy was selling. It was very technical sounding mathematical garbage, and nobody called him on it. And it became this hugely influential idea that still gets repeated. Nowadays, people are smart enough, they don't use his exact numbers, but this idea that there is some kind of critical ratio between positive and negative feedback still gets repeated over and over again. For the simple reason that somebody didn't have the right expertise to peer review a paper. So that is what peer review is designed to stop. Peer review is designed to make sure that there are no glaring errors. Not that there are no errors, period, but that there are no glaring, basic, fundamental errors. Too often, peer review gets bogged down in the same kind of review that you do of other people's writing. So when you read somebody else's writing, like what we've been doing in this class, we've been talking about concepts like clarity and, are you explaining things properly? And you forgot a period over there and this sort of stuff. That's not really the point of peer review. Peer review is not a grammar check. Peer review should be asking the question, are there scientific errors in this paper? Have they presented their data in such a way that it supports the conclusions they're drawing? So I'll give you another example. This is far less egregious. I was asked to review a paper a few years ago that was talking about large numerical simulations of convection in the interiors of stars. I know a fair bit about that. That's my area of research. So I review the paper. Well, the paper, it was overall a very good paper, but one of the major claims they were making in the paper was that there was a trend, that they had deduced a trend with this certain parameter in the convection. And their evidence for this trend was that they had done 2 simulations. Now, these simulations are very expensive and very hard to do, but they had done 2 simulations and they had seen a trend. The simulation with the lower value of this parameter had one response, and the simulation with the higher value had the other response. So clearly you can draw a line between those two and extrapolate a trend, right? So what's the glaring logical error there?
Are they not correlated?
Well, that's what they were arguing, right? They were arguing that there's a trend there. They're arguing that because they had 2 points here and here, that clearly there was a trend.
I feel like there's just not enough like evidence, like enough data.
Exactly.
Yeah.
Any 2 points will do that, right? Because any 2 points make a line. So arguing a trend based on 2 data points is just plain wrong, right? Even if the trend that they were arguing makes sense and is logical, you can't argue a trend based on 2 data points. You need at the very minimum 3, and really to do statistics, you need more than that. So my role as the reviewer was to basically say, look, these parts of this paper are solid, but this piece, which in that case was a big piece of the paper, is not supported by their evidence, and here's why. And to their credit, they didn't fight me on this. They said, okay, that's a valid point. And they went out and they ran 2 more simulations, and then they had 4. 4 is still pretty shaky to argue a trend, but they at least could display something and say, this is what it looks like the relationship would be, okay? And so we were happy. With 4 simulations, we were happy. Now, that's a lot of work. That required them to run 2 more simulations than they had been planning, double the number, which is quite, I mean, computationally, this is talking about tying up supercomputer time for months. But if they want to make the argument, right, in science, it doesn't matter how compelling you feel the argument should be. Only thing that matters is, does the data support the conclusions? Okay, so that's really the question you should be asking yourself. Does the data support the conclusions? Now, of course, they have to describe how they got the data, right? Just pulling numbers out of a hat isn't what you need here. So in other words, they have to, the questions you should be asking yourself are, do they motivate the experiment, right? Whatever their thing they were looking at, do they motivate why they were looking at it? Do you understand why this is interesting or important? Do you understand how they collected their information or their data, right? And I'm using data here in the broadest possible sense. Data can include results from simulations. Data can include results from other people's papers. Data is simply the information that backs up their claim. And then, of course, does the data support the claim? Those are the questions you should be asking in the peer review. Now, if you see things that would help the clarity of the paper, would help the grammar, would help the structure, that's fine to note too. But the real point of peer review is not to check their grammar. The real point of peer review is to check their science. Now, it is entirely possible and quite probable that some of your papers, well, let me stop there for a second. Questions, comments?
I don't have any questions.
I don't have any questions. I do have the comment that Dr. Ayers sent like a little form to fill out or something. Are we supposed to like kind of fill this out and write like what we think and then send that?
Yeah, let me look at that, what he actually sent you.
I mean, it looks like a good thing to use, but I'm just wondering like, or if this is just a like general idea of what we should be sending.
Yeah, I mean, this would be a great, yeah, this would be quite useful. So you could absolutely use this form and just respond to these questions.
Cool.
Yeah, I like this. I didn't realize he sent this to you. Cool. Ah, he stole it from the American Journal of Physics. Cool. Yeah, so that'd be a great thing to walk through and just answer those questions. You know, yeah. Okay, the other thing I was going to say is this journal is targeted at upper division undergraduates. You are upper division undergraduates. So if there's material in here that you don't understand, it's perfectly fine to say, this needs more explanation or more background, right? It is likely you will get those comments back yourself. That's okay. That's the point of doing this whole process, is you're giving somebody who is at the level the journal is targeting to understand what you're saying, right? So feel free to tell them that this doesn't make sense, or that I don't understand this, or can you provide more background, and one way they may do that is they may add in references, right? They may say, for a derivation, C, and then they'll reference a textbook that shows the derivation of, I don't know, the reflection and transmission coefficients in quantum mechanics or whatever, right? So those are the kinds of things that are normal to do, because they don't necessarily need to repeat it all, but it should be unpackable, maybe is the right word. If somebody looks up the references, they should be able to figure out what happened. Okay, questions? All right. Well, I think we'll be short today. For Wednesday, what I'd like you to do is have a couple of reads through the paper you're going to be reviewing, and come ready to highlight a couple of things that maybe you have questions about, or things that you think are issues, questions, comments, thoughts, concerns, right? And we'll talk over them, and we'll just take turns working our way through the class and talk over all the questions on Wednesday. Does that sound good?
Yes, it does.
Okay. Well, great. Then I think we'll probably call it a class today. Great job on the drafts. Yeah, happy reviews.
Thank you.
Thanks.
All right.